Hello. Okay. I hope it's working now. Hi, I'm Lin Pham, and today we will talk about passive sensor. What is it? What is it? And how can it be used in logistics? So basically, a passive sensor is a type of sensors that doesn't require any external power source to operate. You know, Instead, it relies on energy of the physical phenomenon to measure as well as provide the power for that sensor. For example, a passive infrared sensor called PIR is a type of motion detector that use the energy from the heat that emitted by moving object to detect motion. Passive sensors are often used in low power application uh, where it's not practical or possible to provide a continuous power source. And they are also used in case where it's desirable to have a sensor that is self-powered and can operate indefinitely as long as the physical phenomena being measured is there. It's and Yeah, basically it's typically smaller, lighter, and less expensive than the active sensors nowadays. Um, which requires an external uh, power source to operate, but they may not be as accurate or may have like a wide range as or have that as wide range as this active sensor. You know what I'm saying? And they may be more sensitive to interference or noises. For examples, common passive sensors including thermocouples, thermomisters, piezoelectric sensors, and photodiodes. Um, these sensors are used in wide range of applications, including temperature sensing, pressure sensing, sound sensing, and light sensing, so to say. And what does it do in logistics? In logistics, passive sensors can be used in the logistics to kind of monitoring and tracking various parameters such as temperature, humidity, pressure, and maybe more. For example, a passive sensor, a passive temperature sensor, what's it called? Yes, it is. Um, could be used to monitor the temperature of goods during transportation to ensure that they're being stored in the appropriate environment. This is a really important factor for preventing moisture damage for products like food or something, or maybe medicine, healthcare, as well as for maintaining the quality and their life of certain ones. And the passive pressure sensors can be used to monitor the sensor of gases and liquids, such as in the tires of a truck or trailer. This can help ensure that the tires are properly inflated and help to prevent accidents or breakdowns on the trip. One advantage, I might say, of these passive sensors is that they do not require an external power source, which makes them easy to install and maintain. So and because they're smaller and lighter and like less expensive than an active sensor, it makes them well suited for use in logistics where cost and weight are often important considerations. In the wider picture, I would say the use of passive sensors can help improve the efficiency and safety to the transportation and the shortage for goods by providing real-time data on various parameters that can impact the quality and conditions of them of the good. Okay, so I will talk next to the passive sensors principle. Uh, you know, how is it working, and what is it with uh, you know UHF frequency, and the working principle. Oh, sorry. Can I? Oops. See here. Okay. Um, working principle. Uh, the working principle of a passive sensor, it really depends on the specific types of sensor being used. Uh, I can get you an example. A thermocouple, it's a type of passive temperature sensor that consists of two different types of metal wires that are joined at one end. And when the temperature at the junction between the two wires changes, it causes a small amount of voltage to be generated in the wires, and this small voltages can be measured and used to determine the temperature outside. And the passive sensors, uh, wait, how is it not working? Okay, passive UHF sensor. How what is it about the frequency and stuff? So basically, a passive sensors, not actively transmit a signal, but rather detect and responds to external stimuli. So a passive UHF sensor would be a sensor that operates in the UHF frequency range but does not actively transmit a signal. Instead, it would detect and respond to external signals in a UHF range. And passive sensors can be used in a variety of applications, like security, surveillance, environmental monitoring, industrial automation. They are often used because they do not require a power sources or having a limited power requirement, which makes them really suitable for use in remote or hand to reach, so to say, locations. And how many companies actually producing these passive sensor? So there are many companies that produce passive sensors for a wide range in applications. Uh, Passive sensors are used in varieties of industries, automotive, aerospace, electronic consumption, healthcare, so forth, so forth. So forth. And some of the major companies that produce massive sensors, is Honeywell. This is a global technology and manufacturing company that produces a wide range of passive sensors, including temperature sensors, humidity sensors, and flow sensors. And the second one is pretty famous. It's Omron. This one is a Japanese company that uses a wide range of sensors, include passive sensors for temperature, humidity, and motion detection. This is a pretty uh, interesting one. And the third one is the TE Connectivity. It's a global manufacturers of sensors and connectors that produces a wide range of passive sensors for temperatures, pressures, humidity, and other applications. And the fourth one is Sensata Technologies, same thing, and XP Semiconductors, same thing as well. There are just a few examples of many companies that produce passive sensors. There are likely many other companies actually uh, that produce passive sensors for variety of applications. Okay, and the forecast for the usage of RFID, I would say it is really difficult to accurately forecast the usage of RFID in the future. It will depend on various factors, such as technologies advancement, market demand, adoption of RFID by different industries. But I can see like clearly it has been and will continue to be widely used in a variety of applications, including the supply chain management, assets tracking, or inventory management, so to say. And one possible trend is the increased adoption of RFID in retail, when RFID tags can be used to track and manage inventory as well as to enhance the shopping experience for customers. And the RFID technology is already being used in some retail stores nowadays to enable the self-checkout. That is RFID. And it is possible that it will become more prevalent in the future. I would say another area where RFID maybe see the increased usage is in the healthcare industry. Where RFID tags can be used to track medical equipment and suppliers, as well as for patient identification maybe, and tracking. RFID technology really help to improve the efficiency and accuracy of medical record keeping, as well as to enhance the patient safely. uh it also likely that RFID will continue to be used in transportation and logistics, where it can be used to track the movement of goods and vehicles, and to improve supply chain efficiency. Overall, it's just really difficult to predict exactly how RFID technologies will be used in the future. Maybe 10 years, maybe 5 years. It's hard to say, but it's likely that we will be continuing to, valuable tools. It's going to be a valuable tools for uh mass range of application for many industries. Yes, and the working principle of a sensor tag. Um, Yeah, it's just basically a tag based on the ability of sensors to detect like changes in the physical parameters, measurements that being measures, and converting those changes into electrical signals. The wireless communication modules on sensor tag is used to transmit the data collected by sensors to nearby devices. Uh, that, as the example of nowadays is smartphones or tablet, which can then display or protect and process the data as needed. We could say like mm, a temperature sensor maybe. On a sensor tag may consist a thermistors, which is like a type of resistor that changes the resistance based on temperature. So when the temperature changes, the resistance of the thermistors also changes, and this change is converted into electrical signal by sensor tags. And the wireless communication module on sensor tag can then transmit this data to a nearby device for display or further processing. In this way, the sensor tags can be used to, you know, monitor tracks and various physical parameters in real time, and to actually providing the valuable data for a wide range of applications. For as we all know nowadays is assets tracking, environmental monitoring, and yeah, so many more. And thank you for listening. Have a good day.